Hello, everyone. Welcome to this session about strategy for cloud-native application development and migration, Oracle Database Containers, Kubernetes, Oracle Database Operator, and DevOps. My name is Kwasi Mensah. Here is our disclaimer. Okay. And here is the agenda. First, we're going to talk about Oracle strategy for cloud-native application development, then the migration solution for database and applications, then Oracle Database vision for modern application development, Oracle Database Containers and Kubernetes. Then we'll talk about the Oracle Database Operator and its architecture, and then show you a demo of the Oracle Database Kubernetes on the Oracle Container Engine, OKE, and then talk a little bit about our roadmap. Okay, so what is Oracle strategy for cloud-native application development? Our goal is to provide scale, elasticity, resiliency, and flexibility. And that for everything, right? Whether it's containers, microservices, GitOps, DevOps, etc., APIs, operating system, low-code, mobile, AI, machine learning, languages, and frameworks. So whichever we will provide scale, elasticity, resilience, and flexibility. So what are the components of the Oracle Cloud Infrastructure? At the highest level, we have the applications development services and tooling. And you can see we can support any language or tool. DevOps, cloud native, frameworks, Java frameworks, but other frameworks as well. APIs, management, streaming, and messaging. So all the tools of the development services and tool to build a cloud-native application. Then we have the OCI data and AI platform, where you can see all the AI services. You can see the generative AI, machine learning. You can see the data services, including the Oracle database itself, the autonomous database, NoSQL, Exadata, MySQL, HeatWave, etc., object storage, etc. And then the infrastructure, the core infrastructure, which will give you all the compute, all the Kubernetes engine, the container instances, Oracle functions, storage, etc., etc. So that's a comprehensive view of the Oracle Cloud Infrastructure and application development platform. On the side, you have the observability and management, as well as security and governance. Those are also integral part of the Oracle Cloud Infrastructure. Okay, so what are your modern application development challenges? This is a question for you. I know you're not gonna answer me live because this is a recording. And then what are your modern application development in terms of migration to the cloud and in terms of modernization? In terms of migration solution for database and application, you can migrate the Oracle database to OCI. You need to do some planning, whether it's a business requirement such as downtime, impact, simplicity, or technical requirements such as vision, platform, advanced features, etc., etc. And whatever use cases, whether it's replication, consolidation, migration from other cloud databases, migration from Oracle and ISV application, migration to autonomous database, etc. The method are either you use our automated solutions, such as the zero downtime migration, database migration services, and also enterprise manager database migration workbench. Those are automated solutions. But you can also do it yourself using the recovery manager, data pump, multi-tenant movement, SQL developer, Golden Gate. You can let Oracle or partner do the migration for you. Okay, so after we talked about the database, now the application, how to migrate application to the cloud. You can migrate to the cloud as is. You can migrate the container OCI to container engine for Kubernetes, or move from physical on-premises to OCI bare metal, move from VMware to Oracle Cloud VMware solution, or you can migrate to the other option is migrate to the cloud and re-platform. So VMware to Oracle OCI compute, from physical server on virtual machine to OCI virtual machines, etc., etc. Okay. Then the applications. Migrating applications to OCI, you can see that each of our application frameworks each of them offers a migration solution. You can see migrate e-business suite, JD Edwards, Hyperion, etc., migrate WebLogic, migrate big data, migrate non-Oracle databases, Siebel, etc., etc. Okay. Now let me talk about Oracle database vision for modern application development. So our vision, Oracle's vision, is make modern application and analytics easy to develop and run for all use cases and at any scale. So remember when we started this presentation, we talked about the goal of the cloud platform, which is scale, reliability, resilience, and flexibility. The database is in the same vein. We want application development to be easy. We want it to be for all use cases and at any scale. So that's the Oracle database vision. Okay, when you build an application, you usually have multiple data models. For example, if you want to build a rich catalog, you need not only relational, but you need text. You need spatial for geolocalization. You need binary, things like that. So you need different data model. How do you do that? Well, there are two approaches. There are two technologies on the market. That's what we're calling here is polyglot persistence. Polyglot persistence means I need to persist different data types, because it's not just relational, it could be different, etc., etc. But you can also have specific application requirement, which is a single model for a specific application. Okay, so the technologies today are two kinds. One is the specialized database approach, where the recommendation is to use a specialized engine for each data model. So for example, if you have relational, you will use Postgres or some other. For JSON, for documents, you will use MongoDB. For spatial, you will use PostGIS and Elasticsearch. For analytics, you could use Oracle Warehouse and also Spark, a machine those. Then Neo4j for graph, etc. So you see the pattern here, which is use a specialized engine for a specific use case. That's the specialized database approach. Okay, so the problem with that is each model, each engine comes with its own management, security, SQL dialect. So if you want to build a rich catalog, for example, which use multiple data models, while you end up with juggling with, moving data around and, okay, it's difficult. It's not easy, right? For example, for administration, for operating, you need multiple Kubernetes operator. You need one for each of those engines, for example. How do you do cross-model query, right? Because each engine has its own SQL dialect. Okay, so the second approach, and Oracle is not the only one providing this multi-model approach, we call it converged database. So the converged database gives you the same data models, but with a single engine. The single engine natively supports all the data models that you will require. For example, relational, Oracle is well known for relational. Well, you know that for a while we have been supporting JSON natively, spatial also natively, text, and supporting different type of analytics such as warehouse, graph, etc., and new workload types such as microservices, IoT, blockchain, etc. And you can manage all those with a single database operator that we'll talk about in later time. I mean, manage the life cycles and a single SQL dialect, right? Single security mechanism, etc. So your pick, take your pick, but I'm giving you the choices that the benefits or the issues each model presents. So there are some survey questions here. What are the benefits of DB Operator when you're using the Converged database? As I said, you manage a single DB operator can manage all your data models, right? So what I'm saying here is you can have multiple database instances, but it's still the same converged database, and you are managing all this with the same DB operator. We are not saying that put all your data models in a single database engine, a single storage. No, we are saying you can have multiple instances of the database, each carrying different data models, or you can combine, models on a single engine. But the management side is a single DB operator, right? Okay. And then how does Oracle DB simplify DevOps and DevOps? You can see, Converge cross models query, right? Built-in microservices pattern. I don't have time to go over the microservices pattern, but you can see some of them here, such as the Saga engine. And I can tell you that Saga in the database reduces your microservices coding by 80%. Trust me. Okay, now let's talk about Oracle Database Container on Kubernetes. So the evolution here is that we started with Docker. Everybody knows that we have containerized, Docker containerized engine. So you can get the Docker image and you can deploy on Docker. And then we moved to Podman because Podman is more safe. There is no root daemon, for example. Anyway, it's more modern and everybody's moving, and most people are moving from Docker to Podman. So we have an alternative for you for Docker. It's more secure. And we have Oracle images for Podman. It supports OL 8, Oracle Linux 8 or 9, and Podman Compose. Then those images can be moved and deployed on Kubernetes for orchestration, observability, scaling, etc. Okay, and later on, I'm going to talk later on, we do also have a database Kubernetes operator, right? So it's beyond just putting things on Kubernetes. Now you have the operator to manage the life cycles of those databases, because the Kubernetes itself does not manage life cycle, right? It's not automated. You need to do manual. You need to have a bunch of scripts. So that's not the purpose of Kubernetes itself. right? So you need an operator. So these are the evolution of Oracle support, containerized database support. And you can see the version, containerized database 8 and Kubernetes cluster is support for single instance, globally distributed, true cache, CMAN, connection manager. Then you have OCI, where you have the autonomous database, and you have RAC. You have the base DB with RAC, and you have multi-tenant database with RAC supporting on Exadata, on PDB, CDB. And for each in the columns, you can see which images are supported, 1922C, for example, 19C, 22C, 21C, 23AI free, etc. So those are the images. And on the third column here, you can see the deployment. You can deploy on OCNE, which is the cloud native environment, which is on-premise, right? And you can deploy on the OKE on OCI. And you can see the version which are supported and some comments here. There are some resource limits for 23AI, for example. Okay. Now let's talk about the Oracle Database Operator for Kubernetes, DevOps, and CI/CD. So here is the architecture of the Oracle Database Operator for Kubernetes. The dotted line, the box here, this box is the Oracle Cloud Infrastructure. It could be deployed on non-Oracle Cloud. For example, it has been tested and validated on Azure, AWS, Google Container Engine, for example. Okay, so it is supported on Oracle Cloud Infra, but also on the other cloud. Okay, so what do we have? In the Kubernetes cluster itself, which is here, which is this one, we have containerized databases, right? Whether it's single instance database or globally distributed database. And then number two, outside Kubernetes cluster, outside, but still managed by the operator. The operator lives is installed and running on the Kubernetes cluster. However, the databases could be outside, right? Or inside the container, the cluster itself, which is number one. Number two is what is called base DB. This can be reached using REST calls. Number three is autonomous database using the Oracle Container Engine APIs. We can reach out to autonomous database from the Kubernetes cluster. And number four are multi-tenant databases based on PDB, CDBs, for example, Exadata, could be reached using REST services. In this case, it's ORDS, which is Oracle REST Data Service. But we are also now providing another option, an alternative to ORDS, which is LREST. But these are infrastructures. You don't need to be concerned about it. You can just pick whatever you want. But in the future, we're going to discontinue the ORDS controller. I'm not saying we're going to discontinue ORDS itself, because number five is ORDS instances. What does that mean? Well, a lot of customers has many instances of ORDS, hundreds or even thousands, and they don't want to manage those manually. Even those ORDS is not a database by itself. We extend the Kubernetes API to manage the life cycle of ORDS instances. For example, provision, start, stop, ORDS instance. Okay. So those are the features and architecture of the Kubernetes operator. And you have all those lifecycle provisioning, binding to an existing physical object so that the operator knows about it. Start, stop, terminate, backup, restore. etc. Here are the features in v1.1 of the database operator, which were released in September 2024. And I can say that starting from v1.0, the operator is production status. Okay, we have released prior releases which were only preview, but starting v1.0, it's production. So v1.1 is production, of course, and has been delivered in September 2024. And you can see the features here. What is the most important is the security aspect, the namespace scope deployment option, which gives you the option to scope the deployment to one namespace as opposed to cluster-wide deployment of the operator. Okay, so they're supporting for Oracle Database 23 AI-free, automatic storage expansion with single instance database, which is known as IDB, TCPS support, patching, blah, blah, blah. Those are for SIDB. And on this side, you have long-term backup for autonomous database. This is an option, the autonomous database, it's self-backup, but if you want long-term backup, you can trigger that using the operator. Wallet expiring specification, and wait for completion option, etc., workload identification. And then we also have in preview mode, observability. Right in that version, we only supported metrics, but you will see that we added something in the next slide. Workload deployment integration on OKE console. I will show you a demo of that. And validation for major Kubernetes distribution / clouds, such as AWS, Azure, or GCP. Okay. And this is the v1.2, which has been released in February, has been released as the time you're watching this recording. It should have been released. I'm recording ahead of the release, okay, to tell you everything, right? Full disclosure. But by the time you see this, it will be deployed, it will be production, it will be released. So what are the new features? Well, we support for RAF replication with the globally distributed database, previously known as sharding, and database cloning with the autonomous database controller, and multi-tenant enhancement with a new REST-based controller, which will support PDB setting with init parameter, asserting deletion policy. Asserting deletion policy is also newly supported with the ORDS-based controller, but that controller will be discontinued in the next major release. Then we added log support for the observability in addition to metrics. And BaseDB now support cloning with 23 AI. As I said, new ORDS controller, which can let you provision and delete ORDS, treat ORDS instances as pseudo databases. And you can see the list of SIDB enhancement, free-light database support, SIDB resource management, true cache support, observer for fail start, fail over, snapshot support in DataGuard, etc. So you have the operator. Well, so which problem itself for developers, right? Developers are not DBAs, right? And developers, they need a test database. While they don't need they usually need a DBA, right, to provision a test for them to clone, to mask data, and they're waiting for database to be ready. And sometimes the deployment, if you are deploying, you pass the build phase and you move to the deployment phase, while sometimes it requires, database isolation, cycling, etc., etc. So there are some issues, there are some requirements that the operator serves for DBAs. So let's see how this will work, right? You have the automation of all the coding, the unit testing. When you pass the unit test, it is auto-triggered to go into the build and integration test. And then when it passes, you have the acceptance test in auto continuous deployment, right? If the build succeeds, it is automatically deployed. If not, well, you have to do some manual step to fix the issue. So the idea is to in this continuous loop, continuous build integration loop, and you fix broken build as the highest priority, right? So that's the continuous delivery, deployment and delivery, the famous CI/CD, right? Okay, so how do you incorporate the operator in this cycle? Well, this is a simplified view of how it will work, right? So you have Jenkins here, Mr. Jenkins here. You create a branch, and Jenkins will create set up the dev database for you. So how does it do that? Well, it uses the operator under the cover, right? It generates a YAML script that the operator will, and it will invoke the operator to execute the YAML script and provision database for you. Similarly, it will invoke or generate the YAML script when you need to terminate a database. So developers don't wait for DBA, they're just in their cycle of doing things as they do, right? One thing we are investigating, we have not yet completely fully done the integration, is tools such as Liquibase or Flyway, which are used to manage schema changes, for example. So we still have to deliver, to work on how this can be fully automated with the operator. Okay, let me show you a demo of the Aura operator. So, the demo. Okay, so the OCI now has something called add-ons. So the operator is one of the add-ons. So you click on add-ons, and then you select database operator, you choose enable operator, and you choose the number of replica. Okay, and then you use the kubectl command, and the kubectl command will execute a script. Okay, and then we can see that it will create, it will provision the database. It will start the provisioning. So OCI comes the operator is pre-installed. When you select the add-on, you can just start the provisioning, executing the YAML script. So the YAML script got executed. We can see from the console that it was provisioned. Now it's available. Since now it's available, well, we can now download the wallet. The autonomous database has the wallet. You need the wallet, right? You need to download the wallet. And to do that, we execute the ATP wallet, YAML. Okay, now we're going to configure a client. We're going to provision a compute node, to connect to the database we have just provisioned. Okay, so this command will provision a client, a pod, a compute node. Okay, and you can now select the SQL Plus command to connect to the autonomous database that you have provisioned. Okay, remember we have downloaded the wallet, etc. So we have all we need to connect. And the wallet and the TNS names.aura are all in the same repository. So now we're going to check the identity to make sure we are connected to the database we have provisioned, and we can check the name, etc. Okay, so that's good. Now we're gonna do we're gonna scale up. So you see the CPU count here is 2. Okay, we're gonna upgrade it to 4. But to do that, we have a YAML file. In the YAML file, we're gonna scale the core CPU, OCPU to 2, right? It was 1, now it's going to be 2. This is different from what the database shows you. Database shows you 2, but in reality, that corresponds to 1 OCPU from the cloud perspective, okay? So after we do the scaling, it's going to move to 4 in terms of scores. We want the core CPU or CPU to be 2, and we want the terabyte to be 2. It used to be 1 and 1. Now it's going to become 2 and 2. Okay, so that's the scaling. So we apply the YAML. Execute the YAML, increase OCPU and storage using the controller. So we will be using the operator to scale up the storage and the CPU side. So you can see that our CPU is now 2, right? And storage is 2 terabytes. Okay. Now we go back to the client and we check the CPU on the instance from the database itself, and it is 4, 4, which is different from the cloud, the OCPU number, which was 2. So 2 OCPU correspond to 2 in terms of a database machine perspective, CPU count. Okay, now we're gonna terminate the autonomous database. So this is the YAML. Okay, we execute the YAML with kubectl. Okay, delete the instance. We're gonna go to the console to check that the autonomous database instance has indeed been terminated, right? So we can see that it is terminated. We go to the console and we can see that it has indeed been terminated. Okay, so that concludes the demo. Now let's conclude with the roadmap. Our roadmap in the next 6 to 12 months. Cannot give you the exact time frame. Okay. So in terms of runtime, in terms of containerized database runtime, we're going to support 23 AI on-premise, and we support Linux 9, okay, and Red Hat kernel. In terms of, oh, Jesus, sorry. Okay, we will support 23 AI on-premise and the Linux 9. In terms of Kubernetes, we're 23 AI on OCNE in Azure and AWS, okay? And then OCNE release 1.9 and OL9, and support for OCNE storage classes, CEPH and Rook. In terms of the database operator, the major changes will be write controller, and something customers have been asking for, OpenShift certification. We did have a certification for the pre-production version, but we're now in production version of the operator, so we need to recertify the operator for OpenShift and have it in the official OpenShift catalog. And by the way, the operator v1.2 is available now in Kubernetes Hub, operatorhub.io. In operatorhub.io, you can now have the Oracle Database Kubernetes operator. So in summary, the Oracle Cloud Infrastructure provides a comprehensive application development platform for modern apps. Oracle provides extensive support for container-based runtime environment for the database. We have the operator, which greatly simplifies lifecycle management for developers, but also for DBAs. The operator is not just for developers. I keep telling this to my people. It's also for DBAs. How do you manage 1,000 databases? You don't do it manually. You need either an army of DBAs or use the operator, right? So the integration of the operator will simplify CI/CD, and Converged database offers you a single engine to support all the data models that you would need for rich applications, such as a rich catalog, or even for specialized application, right? Okay, thank you.